Good afternoon, everybody. Welcome to the next instalment of the Teaching Professional Project. Today we're talking about the topic of problem solving and assessment. And I have two friends with me. My special guests are Dr Lorraine Harbison from Dublin City University and Dr Shauna McGill from Ulster University. Ladies, you're very welcome.
Thank you.
We met quite a few years ago now.
Yeah.
Started out, we ran into each other at SCO10s and at the MAP group together. And at all those times we had discussions about maths and problem solving and the issues there are for teachers and the lack of resources. And then we got together in a more formal way to put together this project we're going to talk to you about today. So, Shauna, I'm going to turn to you first, and you can start describing some of the topics that we always end up talking about when we're having our coffee, and that is, what exactly is problem solving?
Okay, thank you very much, Geraldine. I suppose really I have to start with a disclaimer because obviously whenever we talk about the word problem, it has negative connotations. So for us, we see it as challenges, mathematical challenges, as opposed to problem solving. And I think as teachers, we have to present them in that exact way because we want children to have an experience of internalising mathematical understanding in a very practical way. I think for us, when we think about problem solving, we have to think about the core skills, about the processes of problem solving, and I think about relating it to real life contexts because that's essentially what we're trying to promote when we think about problem solving in that way. So for us as teachers, it's really, really imperative that we replicate what maths look like in our environment and we utilise real life problems and try to draw out internalising, organising the information of these problems and being able to troubleshoot and giving them to learn the capacity to be able to troubleshoot. And I think for us, it's looking at the skills of deductive reasoning, it's looking at the skills of rational thinking, it's looking at the skills of that exploration, investigation. And these are everyday thinking skills that we're trying to promote in the classroom. And it doesn't sit within the realm of mathematics, essentially. They permeate all the aspects of the curriculum. So I think we have to move away from the ideals that problem solving or mathematical challenges sit within the realm of just mathematics. Actually, they go across the curriculum.
Because so often you find in school that, it's where do we teach problem solving? And it's seen nearly as a separate entity, isn't it? Yeah. But that's not the reality. That's not the way we see it anyway. No. It's a life skill.
Yeah, absolutely.
But then I'm going to turn to you then, because for somebody going to teach problem solving, instead of seeing it as a topic in the curriculum, what skills do we need to teach children when we're teaching problem solving?
Well, I suppose building on what Shauna has said, and Shauna, you're looking at it from the view of the learner, I just kind of pivot now then to look at the role of the teacher in problem solving. And as Shauna was saying, it is an approach to teaching mathematics as opposed to a topic in and of itself. It's a particular approach. So I think we need to kind of demystify it. We don't mean it as word problems, which we tend to see at the end of a chapter of a book. So if it is a chapter on addition, the students know when they get to the word problems at the end, they just add whatever numbers are there, and that's your answer. So it's a particular approach. So just let's say very simple, let's take it as being a topic of addition. A way to do this is to open up the mathematics for children, because we always say, well, mathematics is very creative. Children should have ownership of the mathematics. We want them to be working mathematically. And yet, it's not this idea then, well, they must learn of how to add. So one way will be to present it, maybe by having different numbers on the board, having the children sitting together, possibly in pairs, and saying to look at the numbers. Maybe you'd have two circles, and in one circle you have some two-digit numbers and another circle the same. And get the children just to step back and look at the numbers first, because I think there seems to be this equation between being fast at mathematics and being good at mathematics, which is actually not the same thing. So let's get the children to step back from the mathematics and look at them and saying, well, if you're to add the numbers together, what numbers maybe could you add together in your head? Might it be possible? Have a look at other numbers. Are there other numbers that maybe you could add, but this time it might be a bit tricky to in your head, but maybe some kind of informal jostling and that'll get you your answer. Or indeed, do we need a paper and pencil? So it's that idea of stepping back from it. So rather than doing pages and pages and pages of procedures, actually getting the children to look at, I said keep it very simple with addition, look at the numbers you have and think about how might you solve adding any of those numbers together. So we'd have children, so even a task like that, we call it very low threshold, high ceiling, very inclusive. So some children will stick very closely to the problem. They might take numbers like 3 and 5 and add them together. Other children might take a 2-digit number, 24, and add on a single digit to it, maybe get 5 and get 29. Or others might go a step further and say, but what if I added something like 24 and 37? What might that answer be? So it's actually just taking something that you'd be doing in the classroom all the time, but not directing a solution pathway to the students, opening up the mathematics and allowing them time to think about it, and particularly allowing them time to communicate their understanding.
You touched on something very interesting there, Lorraine, and I know it's a conversation Shauna and I have had many times before, and that's the idea, just when you said at the start there, of a problem being at the end of a topic in a maths book. Because for me, problem solving is about getting away from a lot of that bookwork. And as Shauna said at the start, making it real, that it's not a word problem and something written in the book, but some of the best problem solving activities are not in the book at all. Because something that's very, very important in the whole process of problem solving is the idea of communication. And the children are often working from a book. There's very little communication. You would find that a lot, Shauna, wouldn't you?
Yeah, absolutely. And I think for us, the link from problem solving to the use of mathematical language can be an inhibitor of children accessing problems, because obviously, particularly with children with EAL, English is an additional language, or for example, of children who have very low ability in terms of utilising mathematical language, then seeing it in the context of a problem, again, makes it very inaccessible for them. So I think the dangers and the worries as a classroom teacher that we need to be aware of as we progress with problem solving is making sure that children are well equipped with the mathematical language that's required and associated with the maths concept that we're teaching.
And communication is one of the areas that we're going to be demonstrating when we launch our website at the end of this presentation. But just getting back to the idea of problem solving, and I know, Shauna, you touched on this at the very start, but for anybody out there that's wondering, why do we need to teach problem solving? Why is problem solving suddenly such a big deal? Is it suddenly, or has it always been there? Why is there all the talk about problem solving now?
Yeah, I think as we look at the economy and the demands of STEM subjects, and the skills that is acquired as a result of learning problem solving, then it applies to a range of different disciplines. And I think that, I suppose, for us, shows as teachers the importance of exposing children to be troubleshooters in a variety of different environments. So I think we need to be able to see mathematics as going beyond the subject, but actually seeing it as the skills that we can apply within a variety of different ways and a variety of different means. So yeah, I think economically we have to be able to empower students with the skills that they acquire as a result of exposing them to and allow them to explore problems within maths.
And I think that was one of, just when you mentioned skills, Shauna, that was one of the conversations we had quite early on when the three of us got together, because we were all focusing on the curriculum for our particular area. With us, it's the curriculum from here. With yourself, Lorraine, you were looking at the curriculum across the border. And then we began to sort of move beyond that and feel that the skills that we want to teach aren't tied into any particular curriculum anywhere at all, that these skills are worldwide skills. And Lorraine, maybe you want to come in here and sort of just have a wee discussion on the best way to teach those skills rather than focusing on a curriculum or focusing on a textbook. What kind of things do we need to be focusing on when we're looking at teaching the skills related to problem solving?
So to build on the point I made earlier, it is and should be our everyday practice. So in our classrooms, what we're seeing huge diversity, and we want to celebrate that. We want to have very inclusive classrooms where we're looking at our students as being mathematically literate. So what we're moving away from is the idea of the teacher knowing the knowledge, imparting that knowledge to the students. So therefore they sit there, they listen, and then they reproduce exactly what the teacher has told them. So that is just rote learning, and obviously with plenty of practice, procedures might be able to be reproduced, but they can be forgotten. So what we're trying to do is go beyond that. We're trying to make them mathematically literate. So it's this idea of being able to enjoy, being able to work with mathematics and not being afraid of it, and not being saying, I don't know how to do long multiplication. Yes, I haven't been told, so I don't know how to do it, as if there is only one solution. So what we need to be able to empower students is giving them what we call kind of number sense, play and playful pedagogies. So we've been using them for a long time in our early years classrooms, this idea of play and playful pedagogies. And with not only ourselves, but this has been the move, is to look at these playful approaches right through primary school and hopefully going into secondary school from beyond that. But playing with numbers and really starting to understand them. And sometimes giving problems that mightn't actually even have just one solution. So it's not like, this is the answer and maybe let's work back from it, but just what might the solution be? And let's play with this and let's give up our, different multiple solutions you might have. Or maybe that might have just one solution, and how might you go about solving it? So you could have resources even available to the students. Particularly now we're starting to get into our upper primary years, we're seeing there's a lot of individual seat work, very quiet classrooms, children working away on their own with the textbook. Can be a very challenging environment for students to be in, that kind of very solitary existence. But really starting to think about mathematics as something much broader. So taking maybe some of those problems and exploring them, playing with them together and seeing what kind of solutions that possibly they could come up with. And what resources might you have that can help? Now, not that resources holds the mathematics. So I think we want to emphasize this. But this idea that in particular primary school, if we're trying to build a foundation, can the children see the mathematics? Can they actually justify their solution to you? How do they know they're right? How do they know they're right? Rather than I've learned to solve and this is how I solve this. If you ask them, well, prove it to me, can they prove it? In particular, say you're doing algebra and you're starting to look at patterns. Can they make the pattern? Then extend the pattern and then imagine, well, what would that pattern look like maybe at the 100th term? So it's beyond what's in front of them. So it is a kind of a newer concept, sounds very fancy, and it's called mathematical modelling. So it's this idea of giving them the power to maybe having some of those tools so they can start modelling the mathematics in front of them to imagine then beyond that. So not going in at the abstract, going in very concretely, not learning enough rules, but from actually working through the mathematics, they will actually start to develop those rules for themselves.
The conceptual understanding rather than the procedural.
Having the foundations.
Ladies, I want to share with everybody watching here maybe one of the conversations that, we have discussed and, argued over and come to a conclusion on. It's a point that confused us even at the start, the difference between reasoning and problem solving. Because I think that is something that we need to get clear, because I know on the website we're going to show that. But just have a conversation explaining the difference in reasoning and problem solving.
I think for us, problem solving allows us to promote a rational learner. And reasoning skills are deductive by nature, whereby the child will use various different mediums to explain, individualise, internalise their mathematical understanding. Okay, whereas problem solving presents the mathematics and not necessarily in a context that they're familiar with, but they have to apply that rational thinking and that rational learning and that reasoning to a specific context. And we see it as almost 3 Gs. Problem solving formulates not just given information with a specific goal, but problem solving sits in the middle, the gap. So the 3 Gs is goals, gaps, and the given information. So one of the things we would say is that the gap in the middle is basically the processes by which children learn and understand and show understanding. And that showing of understanding is basically where problem solving sits best, because the learners are having the opportunity to exhibit their mathematical understanding through schematic, logistical methods, or it could be pictorial methods. It's the preference of the learner to show their rational thinking. So for us, I think that sits as an explanation of how they're distinctive. You know, it goes beyond the abstract of producing a goal or an outcome. It actually is very much that process of internalising the maths understanding.
And I think that is one thing we need to get away from in the teaching of maths, that we're not trying to get an end goal of the right answer.
No.
But it's all about the process of learning how to get there. And I think that has been one of our main goals in producing the resources that we're going to showcase today. Just maybe moving on a wee bit from problem solving. A lot of people, myself included, at one time found it very difficult to assess problem solving. And I know this is one of the discussions we had that evolved. The whole idea of assessing problem solving, and it's certainly built into our website. So, Shauna, maybe you want to discuss some of the key aspects of assessment and why is assessment important?
Yeah. I think we have discussed this at length in terms of referring to assessment within our own curriculum and where it sits and the responsibilities of the class teacher, because the class teacher takes on a very different role during a problem-solving activity. You're very much the guide on the side or the facilitator of information, whereby you are allowing the child self-exploration of the mathematical concept. So in terms of assessment, is the subject knowledge of the class teacher has to be very proficient around and surrounding the concepts of mathematics that the child is exploring first and foremost. And then the procedural element of the concept also needs to be taught very well prior to a child ever having exposure to a mathematical challenge such as the context of problem solving. So essentially, you have to be able to give them a framework by which they can extract information, process information, and then present their understanding. So that there's a trial and error element to assessing problem solving. And we're trying to build resilience, that the children are not giving up at the very first point of failure. And that in itself is a very generic assessment. It wouldn't be extricate, it's not, I suppose, linked directly to the assessment of mathematics. It's very generalised assessment of how they tackle the various different problems. But that would be the very first core element of assessment. But in terms of mathematical perspective, maybe Lorraine, if you want to take it from there.
So it very much builds on, I suppose, our learning goals and whatever goals we would have for that particular lesson. But what we're trying to do is understand that particular trajectory, that our children are working along. So to have some kind of an understanding of where they're coming from and next steps in their learning. So when we're giving feedback to the children, it goes well beyond, that problem is correct or incorrect. But we need to be able to identify what is good, what has has been done well in that particular problem, and to give some feed forward as to where they might go next. One lovely way is if we can actually agree those criteria with the children, and possibly even start developing grading rubrics with the children of what does success look like. Because children need to know, what are those goalposts? What do they look like? And sometimes finding success is through each other. So are there opportunities in the classroom for children to showcase their solution pathways? And that is one very valid way. So, it's if when problems have been solved, it's to even ask the question, did anybody solve this in another way? And would they like to share us? But that is such a wonderful opportunity just to celebrate that learning of what it looks like, that diversity of learning, but really is very empowering. So children then know that, oh, I actually like the way, say, Shauna solved that. I'm going to try it now that way next time. So it's this idea of, I suppose, traditionally we'd call it kind of formative assessment, but it has to be planned. It has to be planned. There is obviously in any particular lesson, you're going to be observing the children. There's going to be use of questioning. You'll be circulating the room. But we do need to have a way of capturing that. And that could be a nice portfolio. Could it be something like the children might choose pieces of work or little artifacts that they would like to put in a portfolio? Wouldn't that be lovely that they could share maybe at some of those kind of parent or guardian evenings and say, this is a piece of work I like. But as Shauna, you were saying, it might not necessarily be your traditional sum. It could be a drawing, or indeed it could be a recording. What about a little sound bite of the child's voice? Imagine actually having the child's voice in the mathematics of how they went maybe about solving a particular problem. And this is so possible to us now with the use of technology, that these type of portfolios, I suppose when I started teaching, it was always, like your sugar paper stapled together with samples of work inside. And indeed, there's still a place for that, again, with the ideas of your feed forward in it, but a digital portfolio and what that can actually tell us about even what the child values as being important. So that it's not all about their standardised test results. It's not all about, oh, did you get a 10 of 10? But it's like, I am proud of my work. And here's my work that I would like to share. So it's very much like celebrating what those different learnings look like. And I said definitely use of portfolios is wonderful. Sharing grading rubrics, or indeed developing them yourself, or little checklists. So some lovely ideas there for capturing that assessment information.
I think that's one of the things that excited me as well about our website, was that traditionally, whenever we talk about assessment, you think of tests and scores, and we look at international standardised test scores and things like that. But there are things that they don't capture. You can't capture mathematical communication. You can't capture working with others. You can't capture that whole conversation that you maybe hear two children having with each other when they're rationalising and reasoning and looking at that. You can't capture that just through pen and paper. And I think that was one of the things that I found very exciting about the Mastify website, was that, there are different ways. You can have photographs, you can have sound bites, you can have videos, you can have a drawing, you can have a traditional sum if that's what the child wants. We're not saying there's not a place for that. But there's so many other ways of capturing, and every piece of information there can be assessed by the teacher, because the teacher will be able to replay those and hear the mathematical thinking and the mathematical language. And it's just such a very rich way of capturing the assessment. I'm looking forward to seeing more of those. So we have been developing our website now for about a year. We've been working on this, haven't we? Yeah. And putting together the problems, the solutions. And one of the areas that we did debate about and took time to develop was the grids and how actually to measure. Because at the end of the day, the teacher has to measure the child's progress. And it is lovely that children can come up with, as you said, Lorraine, their progression pathways. But ultimately, the teacher does have to decide where the children are at and where they're going to next. So maybe you want to talk a wee bit, Lorraine, explaining what we're going to show now in a minute or two on the website. If you want to explain a wee bit about the website and a bit about the grids that we developed and how they're not linked to a particular curriculum from a particular country, but there's an international feel to it because it's the skills that are needed worldwide rather than mapping onto a particular curriculum or a particular development pathway that is laid down in any particular area.
So I think it was ourselves. We began by problem solving ourselves. I mean, obviously the three of us have been working together, and we said we would love to produce something very practical, a shared resource that all teachers could use, irrespective of where that teacher finds themselves. And I say, like, because every school environment is different, you can have your large urban schools, you can have multi-grade schools. So we wanted to have it that it didn't matter where that teacher was teaching, that this would be accessible for the students in their classroom, so that teachers wouldn't have to start coming up maybe with their own ideas, taking lots of time. And as we were trying to say, is we wanted this to be kind of a daily thing rather than problem solving happening during maths week once a year, or indeed just on a Friday, that this would be a particular approach they could produce. So we had to go kind of beyond ourselves, and we started to look at international assessments. Like we looked at things like TIMSS and PISA, that were starting to assess what they called, these kind of process skills, and can call them elements. We said, well, that's actually a better idea. That's probably our way to go. So what we've been using then is a skills through content approach. So we focused on particular skills, which we've called understanding, connecting, reasoning, applying and problem solving, and we have one further one, and it's called communicating. So this makes it, the entire website obviously is very novel. We strongly believe that communicating in the mathematics classroom is very important. And the only reason it isn't being assessed at the moment is because, Geraldine, as you said, those paper and pencil based tests, it's not possible to actually capture what communication has looked like. So we started off with these 4 skill areas, but it is skills through content. So that's where we begin. We look for a skill first, and then we look at the content. So how can we develop that skill that we want from our students, and then we map that onto a particular content area. So when you get that far, we produced really rich tasks. So when we have a chance to look at the website, you'll notice that the tasks allow for learners to engage them at whatever level they're at. So some learners will stay very close to the task, where it does allow for progression for other children then to go further, should they so wish to do so. We've also produced then a bank of assessment resources for teachers, so that when they're implementing these tasks in the classroom, that they've a way of capturing students' conceptual understanding that isn't so easy to capture, as we said, using kind of paper and pencil based tests.
So folks, we're very proud of our website that we're going to now demonstrate for you. It's still an evolving process because we are continually adding to it and enriching it and making it more relevant. And we're going to showcase it to you now today. It's a free resource available to all teachers. And we welcome your input as well. So we're going to show that to you now, and please have a look at the website, give us your feedback, and if you want to join us on this journey by contributing to it, by adding in tasks, by giving us samples of children's work, or indeed by giving us feedback of areas you would like us to add to it, or feedback on tasks maybe you have used that you want to share with other teachers, you will see at the very end, we will give you our contact details, and we would love you to get involved in this project with us.
Okay, so Geraldine, thanks a million for that. So this is the website. Now, everyone, we've only been working on this for the past year, and as Geraldine said, we would love you to join us on the journey. All details, you can see there's a contact us there. We would love you contacted us, and at the very end, we will have a QR code as well if you would like get further to work with this on this. So we had started off, I suppose, initially we were just going to focus on just the math element. But then when we had to look further afield, we realised that those international assessments were looking at both maths and science, which was very much building on our philosophy of mathematics shouldn't just be very limited to the mathematics classroom, but should be embedded across the curriculum and indeed outside of the classroom walls. So we decided we would move move and look at those skills and how they permeate through maths and science. Now, not particularly inventive this time, but we just literally put the two words together to come up with the name for our website. Obviously, math for mathematics, and then sci-fi, but we changed the last I to a Y. So that's literally where our name came from. But as you see, as we go along, all of this has been, we started to look at this from the idea of universal design for learning. So we wanted to be a very inclusive classroom, looking at the principles of multiple means of engagement, expression, and representation. So you can imagine from the purposes of building on tasks that there will be multiple different ways that the students can engage with the mathematical learning, multiple different ways of which they can actually represent their understanding to us and to each other, and then indeed to express us. And our motto is this. So when it comes to assessment, and all of us teachers, we want to move away from those Fridays, tables, tests, etc. Our motto is this. Everyone is a genius, but if you judge a fish on its ability to climb a tree, it will live its whole life believing it is stupid. For us, mathematics is for everyone.
But I think the dangers of this, of course, as a teacher, is that if you present mathematics in multiple different ways and outcomes, then this becomes a challenge as a teacher to be able to facilitate and engage with all these different methods and assess all these different methods and representation of the mathematical understanding. So I think for us, that's why this website became very much a collegial effort, whereby it's not just for teachers, but it's created by teachers. And for us, I think that when you as a teacher and a practitioner can contribute to the website of perhaps mathematical representation that you hadn't planned for, I think that's a significant contribution for us, because we want to be able to see alternative ways of presenting mathematical understanding, and children will ultimately surprise us as practitioners in doing so. So that's why this is particularly useful.
And quite often children will come up with a way that we hadn't thought of, that isn't on our progression plan. And sometimes just giving them that wee stimulus. And for teachers, the hardest part was probably finding the starting point, or finding I don't want to use the word the problem, but certainly finding something to present to children that was accessible to everybody in the class, and then let them have ownership of the learning and take it their way. And hopefully on the website, that's one of the things we're going to show you, how different children maybe interpreted different things in different ways and produced maybe a different outcome to what it was, but again, looking at their mathematical thinking.
So we might just explore some of the assessment resources. So you will see from the outset that it's not linked to any curriculum, as we mentioned. It's not linked to content areas, but it is focusing on this idea of mathematical literacy. What does it mean to be able to work mathematically? So we're just dipping in and out of the four different skill dimensions that we have highlighted here. And maybe just talk you through some of the ideas, but you can actually see you will spend a bit of time maybe just kind of playing with this. So let's see, can I get ourselves in? Okay, so just looking at the very first skill, this is the skill of understanding and connecting. So when you start to scroll down through the different tasks on understanding and connecting, you see that each one has like your little thumbnail image, which will give you an idea of what the particular task is about. And those tasks, as you can see, they some of them will lend themselves to you can actually do them outside of the classroom. They do not necessarily need to take place within the classroom. So I think maybe if we just take one task on each of the page, maybe just to explore. So just choosing, this is just one about ratio. Now, why I'm just choosing this one is it is trying to, often when we would do ratio in class, we were starting to use language like, 5:3 and 2, but it might be just something as open as this idea of giving our students a concept map. So you're giving students a concept map and you're asking them, what is their understanding of? So, what does the term ratio mean to you? It's not like, what does the teacher think, but what is their understanding of it? Given context of when might they use ratio and who else might use ratio? So Shauna, you were talking about the idea of mathematics in real life. So this is an example of a task, and you can imagine this is a concept you want to teach. And you're trying to get children's understanding of what it is. So very, very simple, just a little concept map. You can see that the resources for students, it's just a plain PDF in black and white. So it's not going to cost a fortune. You could obviously have it up on your interactive whiteboard. The students could work on a piece of paper. Indeed, you could print it out and give it to the students. But everything that we're doing is I suppose it's just the minimum of needing really very, very, very cost effective. I said you don't need a maths book, you don't even need maths copies. Really, whatever they have in front of them is obviously what you can use.
And it's also very good then to use those even as a discussion at their table. You're just getting children to don't even have to use it on the whiteboard, just to discuss amongst yourselves.
Yeah.
What is your understanding of ratio?
Yeah.
Because there's always the idea of children learning as much from other children sometimes as they do from the teacher. But giving them, that we, scaffold, that we impetus to have this discussion.
And another thing as well about some of the activities that you see that they're not within the confines of the classroom, and that's deliberate in the fact that we see real world life examples that maths can be applied to outside the classroom walls. So for us, it's not just about promoting collaboration of peers, but it's also about engaging mathematics across a variety of different contexts.
You can even see here in the fourth part of this concept map, it's like, what representations, drawings, charts, graphs, words and so forth might you provide to show how ratio is used? So it is so when we were talking earlier and I was talking about things like kind of low threshold, high ceiling tasks, you can start to see now how that particular task, it really it wouldn't really matter like where children were kind of on their learning trajectory, that all children would actually be able to engage in such a task. Okay, so this is going to be like a very much a whistle-stop tour, everyone, if that's all right. But anyway, so this is just obviously for understanding, connecting, and we'll move into the next area. This area is called communicating, and as far as we're aware, now we could be wrong, but we're actually not aware of another resource anywhere that has actually started to provide resources where we might start thinking about, what does math talk look like in the classroom? What does that look like?
And another thing that I love about this website on the area of communicating is that we did look at an international feel to it, and the tasks are not just in English, because in our schools here, we do have children who are multicultural, we do have Irish medium schools, and there are tasks in Irish as well as in English. I think there are tasks in Portuguese, and that there are a variety of different languages there that the tasks have been translated into. So regardless of your setup or regardless of the makeup of your class, we have tried as much as possible to totally embrace the concept of communication, that communication does not just mean speaking English. Communication can be a variety of languages. It can be a variety of representations. We have the pictorial here. We have the ideas for going out to do concrete. And it's embracing communicating in its widest understanding of the term.
I think also it's important to realise some of the restrictions that the English language has afforded as well. So we have taken a lot of research and evidence-based practice on newcomer families, for example, that have recently moved to our jurisdictions, and the experiences that they have had in accessing the mathematical concepts through the language of English, and how that has been challenging in that there's many alterations of the one concept based on the use of language. So when we take, for example, addition can have a variety of different forms and communicated in a variety of different forms. So for us, I think, as we progressed on the website, that's why we're really keen to have as much contributions from international teachers that deliver mathematics in various different, through the mediums of various different languages.
So I think it'd be nice just to dip into a little task here that we would like to showcase for you. So I'm just going to click on Irish, and you can actually, well, there's obviously two the tasks are available in Irish, but I want to actually draw your attention to this one here. And this task is on the topic of time, and it is TikTok croc goes to the party. So that's actually what it's saying. But I would like to show you what this task is. All right, so when I look here, it says task on Dalta, which means like the student task. So you'll see what it is. This is actually a mathematical story, right? So these mathematical stories were written by our pre-service teachers in Dublin City University. And we worked with Feising Words. Now, Feising Words are available both in Northern Ireland and Southern Ireland. So please, if you are watching this webinar, I'm going to put a little shout out for Feising Words there, but fantastic to work with. So Feising Words came in and worked with our pre-service teachers, and we actually produced a story through the medium of English, and it was the story about TikTok croc and him going to the party. So using the Feising Words a pedagogical approach, you always have to have a protagonist. So the protagonist of the story is TikTok croc, who, I don't know if you've seen Peter Pan, and in the story of Peter Pan, the crocodile in us swallowed the clock. So this is our protagonist of the story. So ever since the crocodile swallowed the clock, the crocodile cannot read the time. In particular, the crocodile has a challenge reading digital time and analog time and can't understand what the difference is between them, is always late, has been invited to a party, and you can absolutely see the shock and horror on the crocodile's face because the crocodile has no idea of when this party is about to happen. So what we have is we have protagonist, we have a problem. And to solve the problem, we need mathematics to solve the problem. So in that then, you have the best friends. And the best friends happen to be Anna, log, and the other friend who is called Digit Al. So you read the story and it's like, can Anna log and Digit Al help TikTok croc to get to the party? So when you start to scroll down, this is the student resource, and you can see there's our nice Feising Word logo. You see our students' herosis. We have the translator, and indeed we have a person from Feising Words who did the graphics. And we teamed up with COG. So COG is an Cuorla Idicus Gaeltachta agus Gaelscoileachta. So they have now started to work with us here in Mathsify. We have 2 such stories fully available through the medium of Irish. So as I scroll down, I'm just showing you that at the start there are, say, a little pre-task that the students might engage with beforehand. Then they go on to read the story. And then then you get to the end of the story, then there'll be a little task afterwards to follow up. Okay, so I'm going to just kind of click out that for a minute because we will show you another one in a second. But these are being piloted at the moment just in 3 Irish medium schools, 2 in Gaeltacht areas and just 1 that is a Gaelscoil. And the idea is that we are going to promote children producing their own mathematical content. So when we were talking about problem solving a little while ago, I think what we're trying to show you now is that we're also getting the children to start problem posing. So giving them agency and ownership over the mathematics goes beyond them solving problems, but actually can they start posing their own problems themselves. So with that, hopefully I'll get clicking back into our website with difficulty. Sean, I just can... Oh, actually, maybe I am back in this. I am back in this. I thought I was still on the same page. I'm not. Okay, I'll go back into my assessment resources, and I'm going to come down to the next one then, which this one is reasoning. These are one of the skills that we already looked at. And again, you see we have a number of tasks here. Again, this one there for patterns, rules and relationships. That was the second story that we wrote. And that one at the moment is available only in the medium of Irish, but I will translate it now hopefully in the next few weeks or so. It should be available in English and multiple languages in a little while. You will also see that as soon as we started to work together, we did start to produce some tasks also in the area of science. Again, these are just reasoning tasks, and I'm going to just like dip in here now to a science task just to give you a flavour from us. You can see it's available in Arabic, French, Portuguese and Spanish for the moment, but again, we're working on this. So your student task is very easy. You click into your student task, and again, very simple. Okay, and what's lovely is the context that's put in. You know, we have found a collection of artefacts on an archaeological dig. We need to clean them in order to help us identify them, and we must be careful not to damage them. We will test a variety of cleaners and coins so as not to damage the artefacts. So it has there the little resource then for the students. And again, then when you say click into the teacher's resource, which we haven't kind of mentioned yet, we click into the teacher's resource. That's why that doesn't come up in full screen. No, I'm just going to go out of here for a second. I don't know why that's come here.
The nice thing about recognising that this is a science task, it allows us to see that actually mathematics and the elements of problem solving are not confined to the subject of maths entirely, that actually problem solving in this instance also permeates the science activities that we've listed. And it's also important to note that we try to implement and use some of the typical mathematical resources, such as coins, that perhaps children nowadays are not really as exposed to within our digital world, and the use of contactless payments, for example. So to have it and to utilise resources, concrete resources, even in a science context, actually shows the importance of exposing mathematical concepts across the disciplines.
Okay, so looking at applying and problem solving, I'm just going to draw your attention to measuring for the moment. And the reason why I'm drawing your attention to that is back to the idea of problem posing. So this particular task was using Maths Eyes, which I'm sure some of you are quite aware of, where the students were brought out into the environment, and they were starting to capture what mathematics might look like in that environment. So when you go into the teacher's resource, you can actually see that what we've actually done is we have looked at that element of applying and problem solving, and mapped it along a particular trajectory of what learning looks like along that trajectory. So from that perspective, we just kind of looked at kind of learners IJ, and I think I might have that slightly wrong, because I think I've missed K somehow, have I? IJK, is this? Or maybe it's wait, so I'm looking at. Okay, so in this anyway, you can see how these photographs were actually taken by students themselves. So as I said, if you get involved, we would be absolutely delighted if you would get involved and maybe showcase some students' work. So what we've done is we've taken students' learning and we've mapped it along kind of a typical trajectory to show how it looks. So you can see at one level, like students pose a problem that can be solved directly. So they have like, how tall are the steps? But at the next step on the trajectory, what about this one? You know, students pose a more open Fermi type problem. So in it, they're looking at the water fountain there in their school. And the question that they have posed, now not teachers, what the students have posed is, you know, how much millilitres of water does this release a day? So there won't be one answer. It's all about how maybe they could solve that. And then maybe the next step on the trajectory, again, is looking at that idea of mathematical modelling. So looking at the solar panels on the roof of the house, and it's kind of estimates how much power that this might produce. So we have a little analytic rubric there for teacher-student conferencing. So if they're actually talking to their students about that work, what are the kind of prompts? What are the kind of things that you might ask them? And indeed, we have made things as user-friendly as possible. So we've developed like little checklists for the students themselves. So we want to start moving into this idea of self-assessment. So we have like very kind of simple checklists where we've broken down the task, like step 1, step 2, step 3, very, very easy. And you'll notice then as we go along, it comes to like that they have to like obviously try to solve their own problem, but then tried other ways to work it out, shared the work with their classmates, and then what about giving one of their classmates' problems a go?
I think what this does as well is encourages the learner to take ownership of their progression of learning, and then they also can keep track of their learning. They can self-assess, reflect upon what they've achieved, and there is the element there of perseverance being developed as they go through the process. But I think for us as practitioners, we're very keen to showcase how we can scaffold our learners, and a lot of emphasis always on our planning process is around differentiation. And I think this website utilises a variety of different resources that can scaffold and promote differentiated tasks very easily.
And it also provides teachers with a wide variety of assessment tools, because any of these resources can be used then as assessment, both an individual assessment and an assessment for learning as to where to go next with your teaching. And as you'll see, it's not all pencil and paper assessments. There's such a variety of assessment there for for the children.
Okay, so there's just kind of maybe one last task therefore that we will look at, and that is the very last one here is we have a task, and it's called What Are the Chances? So in this particular task, it starts off with the story. But what's very interesting about this particular story is that we only have the start of the story. So if I just go down here and see if I have it here. Okay, so I'm just going to show you this one, and I should make this full screen, hopefully. Hold on. Perfect. Okay. So in this, you can see it's a story, and it's called like, What Are the Chances? And in this particular story, we've got 2 characters. So one of the characters is called Candice. The other character is called Data. And they arrive on a treasure island. They're trying to find where the treasure is hidden. So in the story, the students are given the opening part of the story, and it's up to them to use chance and to develop their own problems to see who's going to get to that treasure first. Again, no right answer, and we've shown how this can obviously then be assessed on our website. So we're going to leave it at that. You can actually see there is our contact details. We would love if you would get in touch with us. It's mathsify.org, so that's MATHS CIFY, mathsify.org, and we'd love you to get in touch. Thanks very much, everyone.
Folks, on behalf of Dr Shauna McGill, Dr Lorraine Harbison and myself, Geraldine Parks, we are presenting to you today our website so far. Please feel free to use away the resources created by teachers for teachers. Use away, have some fun with it. If you have a chance, give us some feedback on what you think of our website, of things you would like added to it. And indeed, as Lorraine has invited you, if you want to join us on this journey to create this resource, we'd love to hear from you. You'll see on the screen now at the moment, we have our details that you can contact us. There's a QR code there you can scan, which will take you to the website as well. And we look forward to seeing you on the next exciting episode of Teacher Professional Learning Project.